Hello, in this video, we will talk about jointly distributed continuous random variables and calculate corresponding probabilities. So, if x and y have a density function called fxy, they are available in the area belongs to C. This is the whole area. We can say this is a two-dimensional plane, but in some area has the availability for x and y pairs value. So we call this is the joint probability density function for x and y. So because x and y, this is continuous. X and y's value are defined continuous, so we have to use integral to calculate the probability. So this is the probability of x and y available in the area belongs to C. Then we can calculate their probability using this joint density function for x and y. So, for example, x belongs to area A and y belongs to value in B. So we have to use this density function to do integral either dx first or dy first. So we have to use two steps integration. And sometimes you will also want to know, for example, only the x probability. In this way, we can integral one variable out. For example, we can integral y here using the lower limit is negative infinite and the upper limit is the positive infinite. So y is integral out, only left with the x. So the result is this expression. This is also the probability density function of x. So from joint probability density function, we get to the one variable's probability density function. And similarly, we can also get the probability density function of y by integral x out, right? So next we take a look at an example. We know the joint density function of x and y is given by this expression. So both x and y appear in this expression, and this is the limit available value for x and y. Both are positive continuous area, right? Then the question is, first compute the probability of x larger than 1 and y less than 1. This is simultaneously availability of these two variables. And the second is the probability of x less than y. And the third question is probability of x less than a, where a is a scalar value. So we make solution step by step. The first is quite easy because we have to calculate x larger than 1 and y less than 1. Both are scalar, right? So we just take the integral of, for example, x first. Because larger than 1, so we use the lower limit 1 and upper limit is positive infinite for the dx. So we integral this part out first and get this value. Then this is out is only without x now. So the second step is to take integral of the expression with only y, but here we can take e minus 1 power out. Then we use integral for this expression, then get a result without x and y. Right? So the first question is quite easy to solve. And the second, we have to calculate the probability of x less than y. This is quite a puzzling at first. But if we look at this figure, this is y equal to x. So where is x less than y? Actually is this part, right? From this black axis and with this red line, or this area up. Because this is y equal to x, and here is y less than x, and here is y larger than x. But we have to keep both x and y positive value, right? Because in the question is y larger than 0, x also larger than 0. So we have to only calculate this area for the integration. No, not this area, not this area, not this one either, right? So only this part of the area. So here we use two steps. But here we must integral x first, because we have to integral to make one variable out. So here we can only do integral x first, and x, the value, the lower limit is 0 and upper limit is y. So we take this direction for integration for x from 0 to y, right? Then second step integration is from 0 to positive infinite for the dy. So here we just calculate the first integration with this expression and dx and from 0 to y. Then this result will be this expression, no x now, only y. So it's quite easy. We take integral from 0 to positive infinite for dy, right? So the result is 1 of 3. And the third question, x less than a. So this is same to say just we take the integration of y out first. Then take a second step for integration with x with 0 in up under lower limit and a is upper limit, right? So this is quite easy two-step integration. This is the first one. First step for integral of y, then second is dx. Thanks for watching.